In level 2, it's going to be really important to know your parent functions really well from level 1. And all you're going to do is shift them around the graph using transformations. So just left and right and up and down. Remember that when you have a number added or subtracted on the inside by the x, it shifts it side to side, and it's always counterintuitive, so you shift the opposite way of what you would expect. And then a number added or subtracted on the outside is a vertical shift, up or down, and that one's always straightforward. So this -3 on the outside is going to be a vertical shift. And it's going to go down 3. So if we take our original graph 2 to the x and shift it down 3, we're going to start by moving the asymptote down 3. And so at -3, I draw my dotted line. Now, normally when I graph 2 to the x, I start at the origin and go straight up 1. So I kind of like to imagine my starting place moving down to down 3 as well. So from there, my starting place, which I put that little kind of red plus sign as my starting place, I move up 1, and that's my first point. And then my next point from the origin, I always went right 1 up 2. So from my new starting point, I go right 1 up 2. And my next point would be right 2 up 4. So I go from my starting place, that little red plus sign, right 2 up 4. And then right 3 up 8. And from my starting place, in the normal graph, it's left 1 up 1/2. So left 1 up 1/2. And that's enough points. I just need to draw the shape of the graph. And again, it approaches the asymptote going to the left, never touches it, and increases quickly to the right. And I didn't draw that very well, but good enough. Okay, the domain of this graph is -infinity to infinity for all exponential graphs. The range, since it moved down, my lowest y value is approaching -3. It'll never hit -3, so I do a parenthesis, -3 to infinity. The asymptote moved down to y equals -3. It's horizontal. The limit as x approaches -infinity. As the x values head to -infinity, the y values are all heading towards -3. And as x approaches positive infinity, the graph shoots up. So the limit as x approaches infinity is positive infinity. In this next example, we are transforming the e to the x graph. So the -2 on the inside by the x, it's a horizontal shift, but instead of going back 2, it's going to go in the positive direction 2 units, so to the right 2 units. So there's a horizontal shift. And that is right 2. And a vertical shift up 1. So we start by moving the asymptote again. An exponential graph only has its asymptote moved if you have a vertical shift, which we do. So we shift it up 1 and draw that dotted line. And then again, I like to pretend that I'm moving my origin or my starting place. So I figure out where I'm moving that starting place to be, and it's shifting right 2 and up 1. So right 2 and up 1 gives me that point right there, 2, 1, as my new origin. It's not really the origin because the origin doesn't move, but it's my new starting place for this graph. So when I make my first point, normally I start at the origin and just go up 1. So I start at my new starting place and just go up 1. And then my next point is to the right 1 and up 2.7-ish. So from my starting place, I go to the right 1, up about 2.7, and draw the shape of the graph. And the domain is still negative infinity to infinity. The range for this graph, the lowest y value is 1, or it approaches 1, so I use a parenthesis, to infinity. The asymptote is horizontal, and the equation of a horizontal line is y equals, in this case, 1. The limit as x approaches negative infinity, as we head out towards big negative x values, the graph approaches y values of 1. And as the graph approaches positive infinity, it's shooting up to infinity. In the next example, we are shifting a natural log graph. We have a +3 on the outside, so that's going to be a vertical shift, and it's going up 3. When I move this graph up 3, the asymptote is not going to be affected, so I still do my asymptote on the y-axis. And I just move the graph up 3. So again, I like to move my starting place or my origin up 3, and I get my new starting place. From there, I make my first point to the right 1. And my second point from my starting place is to the right 2.7 and up 1. About right there. And then we just draw the same shape of the graph. The domain of this function is still 0 to infinity. The range is still negative infinity to infinity. The asymptote is x equals 0. Vertical lines always have an equation of x equals some number. And the limit as x approaches infinity is infinity. And the limit as x approaches 0 from the right side is negative infinity, because the graph is going down as we head towards 0. In this next graph, we're transforming the log graph. We're shifting it. The +4 on the inside is a horizontal shift, and it will go to the left 4 in the negative direction. So shift left 4, and then the -2 on the outside is going to make it go down 2. So the asymptote is going to move in this one because we're moving to the side. So I move the asymptote to the left 4 and make a dotted line. X equals -4. My new starting place, if I imagine my origin moving to the left 4 and down 2, I get a new starting place about right here. And from there, my first point goes to the right 1. My next point goes to the right 10 from my starting place and up 1. Which puts me right there. And that's the ordered pair there is 6, -1. And we draw the shape of the graph, same as before. The domain of this function is -4 to infinity. The range is negative infinity to infinity. The asymptote, which is vertical, is x equals negative 4. The limit as x approaches infinity, this graph is going up as the x values get bigger, so the y values approach infinity. And as x approaches negative 4 from the right side, the graph is going down to negative infinity.